Thank you for everybody for coming. Today is our Fusion 360 workshop hosted by Autodesk with the expert Gabby here. And today is going to be focusing a bit more on to prepare people to use Fusion 360 for our upcoming glider competition starting in early March. Gabby, thank you very much for coming again today, and I'll hand it off to you.
Absolutely. Sweet. So we'll go till 7. So I'm going to do a bunch of demos. This is going to be more a watch and learn workshop rather than a follow along, but it is being recorded. So if you then take the recording, you can go and follow along from the recording. But I'm going to do it this way just so we can get the most information in. Right. So the first principle of stuff for a glider, right? So you're all making gliders. So the first principle is that you're probably going to need to use the lofting tool. So we're going to spend a lot of time on the lofting tool today. And I'll start out real basic. So in my workshop so far, if you've been to them, we've probably done like extrudes, revolves, and maybe just those two. Maybe we've done a sweep, but I don't think we've done a loft yet. And a loft is a pretty unique tool, and it's meant to be used when you can't get the form you want from basic tools like extrude and revolve. So let me show you quickly how it works. So a typical, like the quintessential case for a loft is when you want to make a circle that turns into a square. So I'm going to show you that right now. So we're going to make a circle. And I'm not going to do dimensions just because it's for demonstration here. I'm going to make a construction plane that's farther out here. And then I'm going to make a sketch on that new plane. And I'm going to make a square or rectangle-ish. Seems good. So if I wanted to basically make a form that starts as a circle and merges into a square, extrude would not work, revolve would not work, and sweep would not work. Because sweep, what it does is it takes a constant profile and sweeps it along a path. Think of like making a pipe or something. So it doesn't change form. Loft is the only one that allows the form itself to change as it goes through different profiles. So we're going to click on the loft here, or click on the two profiles, and it's going to connect them with a solid body. So this is like the classic example of a loft, right? So you're having a circle that turns into a square profile. And this is really a great use case for a loft. So you can think of a loft as the tool you'd want to use whenever you are bridging together multiple profiles that are different. So if you have a profile that's consistent throughout, then an extrude will be fine, or even a sweep. But if the profile is changing, you'll want to use a loft. And if you think about an airfoil or a plane wing, right? Those profiles change as you go down the wing or as you go across the profile. So loft is really the best tool for that job. And we're going to go through how to do that today. But just from a very basic high level, this is what a loft does. And I'm going to show you another example here. So let's go back. Let's make a different sketch. I'm going to leave that one there, but I'm going to make another circle out here just to show you a different example. And then we can go and edit our second sketch. And I'm going to take this and I'm going to offset it. Oh, sorry. First I have to project it. So I'm going to project it into my current sketch. And now I'm going to modify offset. So I'm going to take the same one and I'm going to put it, maybe make it smaller or bigger. And just like that, I can get out and I can do a loft now between those two. So I start with this sketch and I'm going to go to this smaller sketch. And the cool thing about this is that this is now an offset from this main sketch. So I can pull this out, it's going to update, and it's going to keep that offset constant. So if I make this smaller, the offset is now going to stay constant and change as a result of this sketch since I projected it off this sketch. So this is another way you can use loft. If you want it to be if you want it to go from one diameter to another diameter, and you need to specify what those two diameters are and also the distance between them, loft is a really great tool for that. Okay, I'm going to do one more example here. So we'll keep going to the side. So that's with a spline. So I don't know if we've used splines much in my workshops, but a spline is probably like the least parametric tool in the parametric sketching workspace. So when I say parametric, I mean that it can be controlled by equations, by dimensions. And splines are, they're a sketch tool, but they're really hard to control with dimensions. You can see I'm making just kind of a free form thing. Right? And anything I do here can move. So, I can pull this up, I can pull it down. If I click on any of these points, there's this green line, that's the tangency control. So I can make it more tangent. I can bring this out to expand the tangency. So you can see why these are hard to dimension, right? They're sort of meant to be more freeform. So I'm not going to dimension it right now. But I just want to show you this is another kind of form that can be lofted. So before I was doing like two planes, right? So I made another plane out here, but I want to show you that you can also just copy. So I'm doing Control C, and now I'm doing Control V. Oops, I have to be inside my bad, sorry. I have to be inside the sketch. So if I click this and I do Control C and then Control V, you'll see how it brings up the move copy dialog. And now I have a second one here, and I can move this off the plane. So what I did there is I basically made a 3D sketch. So I copied and pasted and I moved it off of the plane. And once I'm here, maybe I want to rotate it a little bit to give it a bigger angle of attack. And then what I could even do here is I can scale it. So I can scale it maybe from the top. I can do like 0.8. So I can make it a little smaller. I could have also done an offset. And then here I can do another loft. Loft. I'm clicking there. And there I get this kind of interesting shape, right? Because I rotated it's a little bit different. It's smaller. So these are kind of three examples of a loft, three different ways to do sketches, right? The big difference is the first two, I made a new plane and I sketched on that new plane. And this third one, I pulled the sketch itself into space to make a 3D sketch. And then I used those two profiles that were actually in the same sketch. So that's kind of the basics of solid loft, and then from there you can do things like fillet. So if I click the fillet command, I can fillet these edges. Oops, too big. Let's do 0.5. So I could fill in an edge. You can cut a hole in it. You can do any other tools that you want to use in terms of the solids. Now, I'm going to hide those bodies and I'm going to show you something else. So we have our three kind of lofted profiles, or three examples of lofted profiles. And we're going to go into the surface tab. So this is another area that I don't think we've really talked about yet. But the surface workspace is it's also parametric, meaning that it's driven by equations. But instead of making solids, you're making surfaces. And surfaces are exactly what they sound like, right? You're not making a solid body, you're just making the external face. You're just making the faces of it. So we can see if we do the same loft, let's start with the first one here. I'm just going to select the edge. I don't need it to be a closed profile because I'm just doing the surfaces. So if I hit OK here, you'll see it's actually hollow. I'm going to hide the sketches for a second, right? It's actually a hollow shape. And that is pretty different. So if we show that surface body, that first one, I'm going to move them actually. I'm going to move the surface body just a little bit over, just so we can see both of them together. So it's pretty clear what the difference is here, right? So we can see one is just a surface and one is just a solid. And there are some really benefits to using both kind of paradigms, right? Like using a solid modeling paradigm or using a surface modeling paradigm. For airfoils, I tend to kind of gravitate towards surfaces because you can control things a little bit finer. Like for example, let's say I wanted to get rid of this face on a solid and I wanted to make that face something else. That's kind of hard to do. I'd have to make the thing I wanted this face to be first, and then it would transform into that. So maybe I would extrude this to be taller if I wanted to be taller. But on a surface, I can literally just click the delete button, and then it's going to delete just that surface. And then I can reform that surface. Like for example, I could do another loft here and just loft from, let me undo chain. I could just loft from this edge to this edge. And now I'm reforming that surface. So that's kind of the usefulness of surfaces, right? Is you can treat each face as independent and modify them with a lot more control because you don't have to worry about editing the whole body at once. Okay, so I'm gonna just do, I know there's some questions, but I'm gonna finish this section of the demo and then I'll get to the questions. So let's just, I'm just going to do another surface loft of each of these just to show you. Whoops. Cool. And then one more here. The same idea. A couple of things about surface, about these lofts as well that we haven't talked about yet is one, the main thing is called a guide curve. So if we go back before this last loft, right, and we can see what it's going to look like if we just do a straight loft, it's going to make the shortest distance between the two curves. Let's say I wanted to follow a different path. I'm just going to make a sketch. It doesn't really matter what plane I pick because what I'm actually going to do is hover over. I'm going to click on both of these and I'm going to go under create, project include, and hit include 3D geometry. And what that's going to do is pull those 3D objects into my current sketch. So now if we hide the original sketch, we can see that they are in my current sketch, which is sketch 3, as 3D objects. And now if I do a spline, you'll see, if my plane is actually back here, but as soon as I hover over these objects, I can snap to these objects. So right here, I'm snapped to it. And, maybe I'm going to do a 3D sketch here. So I clicked 3D sketch on the side. I'm going to do that again. So I'm going to click over here, and then I'm going to click on this plane to kind of, I can click on all these planes to tell my mouse where it's moving in 3D space. So when I clicked on this top plane, now I'm moving in. My pointer is in this top plane, so we can see that here. If we go this way, right, it's stuck on that top plane. And now if I click on a different plane, it's going to change, and now it can move on this front plane. So that's kind of the way to control 3D sketches. But I just want to keep it simple here. I'm going to now anchor it to this other part. So I'll show you what I did here. Right, so I just made a 3D sketch that connects the two right there. And we call that a guide curve. So now if we go back to that loft and we click edit, we're going to add a rail. And I'm going to add that rail, and you'll see how the form changes, right? The rail pulled the loft to one side. So that is that's kind of how rails work, and you can have multiple rails that, maybe if I wanted that on the other side as well, I would have it kind of bulging on both sides. But rails can really pull your form in one way or the other. And then the other and rails you can do with solids as well as surfaces. So if I go and edit my hold on, let me pull this sketch to before. Now if I go and edit this solid, I can also add a rail here, and it's going to do the same thing. And now I just have the solid with a rail. So there's rails are pretty useful as well. Now with surfaces, so all of these surface bodies, like I can't do the fillet the same way, but I can use other tools. So one of them I wanted to show you is a patch tool. So what a patch does is it basically takes a chain, an edge, and it puts a patch on it. You can see it just makes a flat surface there. And if I, let me actually, so there's one patch. And if I do the same thing here, this one, it's on a conical surface, and you can see I can make it a connected patch, which is flat. I could also make it tangent, which will put it tangent to this surface. And I can also do a G2 curvature, and I define the weight of that. So maybe I want to make it 0.8, which will make it, pull it out even more. And then if I do that on both sides, so I'll just do another simple patch on this side. Now I actually have a surface, and then I made 2 more surfaces on the back. And I can actually stitch all of these together to make a solid. So that's the stitch command here. So if I click these 3 surfaces, you'll notice there's a green line between them. And as soon as I hit OK, right, there's body 6, body 9, and body 10. It's going to form a solid body, which is body 11. So you can turn surfaces into solids by capping all of the open edges and then stitching them together. And the same thing with a solid. I can take a solid and turn it into a surface by unstitching it. So this command called unstitch, if I select this body and I unstitch it, now it's a collection of different faces. And those are in your timeline as well, so you can, delete them or go back or whatever. But that's how you would get from one to the other. Yeah. So that's what I wanted to show you for kind of high level lofting. So I'm going to look at the questions now, and then we're going to go through a more long form example of an airfoil. Okay, so the first question is, how does one determine a cross-section shape of wing anyways? Do you wing it? Haha, good one. So that is a good question. Airfoils and ideal airfoils are usually determined through computational analysis. So like when I was an undergrad, I did it through a program called COMSOL. I think ANSYS can also do it. Autodesk CFD is another product that can do it, that kind of tests out these airfoils and tells you how to make them better. In terms of generating the airfoil itself, that's usually done through MATLAB or Mathematica or some sort of differential equation solver. And you're putting in, parameters and things like that, and then solving for a point cloud. I don't know if that's in the scope of this competition. Like, if you, that's basically like if you're designing a vehicle and you have all this data that you need to match, or that you want to compute, and you basically plug all those in terms of equations into a program, and that program would spit out, ideal airfoils for the different conditions that you have. And then you would go and test those airfoils in like fluid dynamics software. I feel like that's probably beyond the scope of this. So what you probably want to do is just go look up airfoil websites. So I'm going to show you. So let's see. Okay. So can screen 3. Can y'all see this screen now?
Hmm.
Yeah, so there's a website called airfoiltools.com, and it's basically it gives you profiles of airfoils. So if you hit airfoil search, I'm just gonna search all of them. So you can see there's a ton of different ones. So like this one's kind of interesting. So if we just click the first one, it gives us a profile of the airfoil, and it gives us a bunch of charts of the airfoil. So CL is coefficient of lift, I believe. And CD is coefficient of drag, and alpha is the angle of attack. So it's basically giving you plots of how it's performing. And then it also has some data up here. I'm not like an airfoil expert, so I'm not sure quite how to interpret it. But I do know that the DAT file is basically, you look at the DAT file, the DAT file is basically a list of coordinates of the plot of the airfoil. So it has a point at 1 and then 0016. And then from this data, Fusion can take it and make a sketch. So that's actually what we're gonna do next. But that's how you would figure out, if you didn't want to make your own airfoil, you can kind of search a database and get data for the airfoils that you want. Okay, second question is, for surfaces, do we need to start from a solid body, or can we start using surfaces from scratch? You can certainly use surfaces from scratch. So when I made these surfaces, I actually didn't start with a solid. I started with sketches. So I lofted sketches into a surface body. So you do not need to start with a solid. You just need to start with a sketch. Same as anything. Probably the easiest way to make a surface is you would just like make a sketch. Let's see. Where's the origin? Yeah, so let's just make a sketch here. Doesn't really matter what that sketch is. There's my sketch. And then I can use the patch tool, and I just click patch. And now there's a surface that is that profile. So all you need to do is start with the sketch. Okay, so I'm going to go through kind of a longer form example about making an airfoil. So we're going to kind of utilize all of these things that we learned about lofts. I only showed you lofts with 2 profiles, but you can have a loft with 100 profiles. So we're going to go through that. So when I make an airfoil, when I made an airfoil today, when I prepped for this workshop, I basically started with a canvas. So I've never really worked with airfoils or made airfoils. So I wanted like a picture to know what I was going off of. So I did something called insert canvas. So under the insert menu, I hit canvas. And all this is just an image file. It's not vector. It's not a vector file. I can't use any of the lines on it. I can't use any of the images on it. It's literally just for reference. So I'm going to go on my computer. Um, I have a folder called decals and canvases. Glider, top view. So I'm going to put it on the top, and I'm going to hit OK. You can see there's that glider, right? Cool. So that's good. I think I want to move it a little bit. So I'm going to hit edit feature, and I'm just going to move it down so that that the origin is kind of equivalent with the top of the wing here. And then the next thing I'm going to do is calibrate the canvas. So right now, this is pretty small. I can tell because I had to zoom in a lot to get to it. So if I right click and I hit calibrate, what that's going to allow me to do is set a distance. So if I click here and I click here, do y'all know how big your gliders are going to be? What the size is generally?
It's probably most likely going to be a volumetric size. Uh, that they'd have to be less than a liter in displaced fluid.
Okay, a liter. So are we looking at a wingspan of like a foot? Sorry, I'm not in metric mode right
Yeah,
now.
I'd say
Like
we
a
could
third of a meter.
probably about 30 meters, maybe about 30 centimeters. Yeah.
Okay, so let's say it's 30 centimeters. And I'm actually going to round it up to, there we go. So now it's scaled. So now it's what we want. I'm gonna recalibrate it and just do the closest amount in inches just so my brain will function a little bit better. So I'm gonna say 12 inches. And now I want to move it one more time. So I get that origin where I want it. Okay, cool. So the next thing I want to do is I want to draw the outline of the wing. So I'm going to make a sketch on the top plane here, and I'm going to make a bunch of lines. I'm only going to focus on one side, and then I'm just going to mirror the body. So I'm just going to do this side for now. Okay, so that's the outline. And I also want to do a couple more things here. So I want to dimension it first. So let's kind of do that. What did I dimension on my other one? I dimensioned this bottom one. So I'm just kind of gonna round it. So maybe 1.2. And maybe I want the total length here. Oops, it's giving me I want this to be horizontal. Why is it doing that? I want to make sure these are straight. Okay. Okay, there we go. So let's maybe say 5.7 on that. Okay. Then I'm going to pull this down. So remember the reason the reason we dimension is because dimensioning shows design intent. So if someone else comes and looks at this, they know what I was trying to do. And also sketches that are undefined can be moved very easily and then they can be broken. Okay, so that's pretty good. Maybe I'll make this slightly shorter. We don't need to get too precise here, but I want the overall one to this. So that looks good. Okay, so what else do I need to fully dimension it? I'm going to set a dimension here that's aligned. So an aligned dimension is, at the same angle. So it's going to be 5.12. And then I'm going to make this the same as this. Okay, that's good. And then I think the last thing I need to do is these angles. So I'm going to make that 163 maybe. And then, so I'm just doing this. I don't have these numbers written down or anything. I'm just doing this based on the image approximately. Okay, so then I'm not sure exactly how this is not dimensioned, but if I pull it, I'll find out. Okay. So I'm going to define it based on the origin here. I'm going to do 0.07. Okay, now it's fully defined. That's great. So a couple other things I want to do here. So we're going to loft this, right? So if I was doing an extrude, all I would need is this profile. But I'm going to loft it. So I essentially am going to want a profile at various points along this wing. so I can loft between them. And the points at which I want the profile, I'm going to define right now. So I'm going to do a rectangular pattern of this line. Okay, actually, before I do that, I'm going to find out what this is. So this 5.68, I want to find out what's the name of that dimension. So if I go under modify change parameters, these are all the dimensions in this sketch. So this 5.68, I'm going to change that to be total length. Okay. So that's important, and I'll show you why. So if I do create rectangular pattern, I'm going to rectangular pattern this sketch line at the bottom. And I'm going to do it in this direction, which is just perpendicular. And my extent is going to be, the extent is like the total length, and the distance of the extent is going to be total underscored length. So now it's going to end my rectangular pattern exactly at the end right here that matches this dimension. That way, if I change this dimension, the way that my planes are set up is also going to change. And I maybe want, how many do I want here? 1, 2. If I was really doing it, like 10 is probably overkill. Maybe 6. I don't know. 1, 2, 3, 4, 5. Sure. Maybe I'll do 7. But you can play around. The more, the more planes you do, the more granular control you have, etc. So what it did is it made these lines evenly spaced. And what I'm now going to do is get out of my sketch and make those lines into planes. So I'm going to use those lines as reference points for planes. So under construct, plane at angle, that's what we want. I'm going to click each of those lines, and I'm going to make a 90-degree plane at that line. So I'm going to do that. And if I right click, I can just go up and repeat the last command. So right click, the thing at 12 o'clock is my last command, 90. So I have all my planes now. That was fairly quick. And I want to show you just the reason we made this parametric. So if we go back to our parameters box, and that we have that total length, right? 5.68. Let's look at it from this way. If we change that, okay, let's make it crazy for a second. If we change that to 7, oh, 7's a little too crazy. Let's change it to 6. If we change it to 6, you'll notice that those planes still are spaced evenly, right? Because we made the planes tied to the lines, and then the lines were an equal they were equally divided with the total length, right? So it's all parametric. It's all linked back to this total length. We have a lot of control over this, and it's not going to make us redefine anything. So that's pretty nice. All right, so we have our planes, and now we're going to bring in that airfoil. So let's go back to let's go back to that. Which one is it? I think it's this one. So we're at this airfoil profile. So I'm going to right click on this DAT file. And I'm just going to click on it. Sorry. And then we have this coordinates. So I'm going to right click and hit save as. And I'm going to save this as, I have a point clouds profile now, and I'm going to call this 20-32 C. And then I'm gonna, yeah, I think that's what I want to call it. Or I'm gonna call it, sorry, my nomenclature here is airfoil and then 20-32C. And then the important part is .dat at the end. I hit save. And then it downloads. And then we go into Fusion, and I'm gonna use a add-in that I created. So under your tools, you have an add-in, scripts and add-ins. And what I did was I went to the App Store and I downloaded this one called Airfoil DAT to Spline 2.0. And if I hit, if I wanted to go to the App Store, let's see if I can do that. So y'all probably don't have that. So if you just go under Fusion App Store, add-ins Fusion App Store, it'll bring you to the App Store and you could search for this app. So let's see if I just search DAT. Yeah, so which one is this called? This is called Airfoil DAT to Spline. So Airfoil DAT to Spline. So it's this one. So you would just download this, and it's available for Windows, it looks like. So if you just download this, then it'll show up and you install it. It'll show up in Fusion under the add-ins. And I can put this link in the chat as well. I'll do that now, actually. And then I suppose I will also put this Airfoil website in the chat. I think that might be useful to y'all. Okay, so I'm going to run this script and I'm going to select a construction plane. So it needs these planes because that's where we're going to put the sketches. So I'm going to put a construction plane. I'm going to select a construction plane for this sketch. And then on the chord is the length of the airfoil from, front to back. So you'll see if I select chord, I hit these 3 dots and I'm going to say measure. And I'm going to click this edge to measure. And it gives me that's 1.2 inches. That's great. So it's going to give me that length, and that's going to be the chord of the airfoil it's going to import. So it's going to scale the airfoil to have a chord length of 1.2. Then I hit OK, and I'm going to go and I'm going to find that airfoil. So that's under point clouds, airfoil 20-32. Okay, cool. So now the airfoil came into Fusion. It came in a little bit of the wrong place, though. That's okay. So we're going to click on it and hit go into our solid workspace and hit move. And I'm going to do a couple things. So the first thing I'm going to do is rotate it. And I'm going to rotate it about this. I showed the origin here, and I'm going to rotate it about the x-axis. I'm going to rotate it 180 degrees. Okay, and then I want to move it so that the nose of the airfoil is right at this point. So I'm going to do a point-to-point move. This airfoil point to the right there. Yep, perfect. And maybe I actually want it to be rotated a little bit so the angle of attack is a little higher. So I'm going to rotate the same thing. I'm going to rotate it about X, and maybe I'll just rotate it 5 degrees. Cool. And then I hit OK. So that's number 1 of the loft. So then we would just do that again. So I'm going to do it one more time, and I think I'm going to skip to my completed version. But actually, before I did that, I want to do one more thing in that sketch. So I want to go back into that original sketch. And I have these lines, which are great, but I actually want to make lines on top of them, because what the airfoil is going to, when I do that airfoil sketch, it's going to ask me where I want to anchor the nose. And I want to be able to give it a point right here. And right now, there's no point at the intersection of this line and the edge of the airfoil. So I want to put a line right there so that I can grab onto something. So I'm just going to put lines right there over the existing lines, but then they give me points at the intersections. So that's important. Okay, and then one more here. Okay. All right, great. Okay. So I'm going to do that one more time here. So I'm going to go into my tools, add-ins, scripts and add-ins, Airfoil, run it, construction plane here. And then again, my chord, I'm going to hit measure. And that way I can go from that point I just made to the other side here. And it's going to do it exactly that point. Hit OK. Going to grab the same airfoil. It's going to probably pull it in upside down again or somewhere else. But at least the chord length is correct. So let's hit M for move. Sketch objects. I'm going to rotate. I'm going to rotate it about X 180. Okay, then I'm going to do a point-to-point move. I'm not sure why it's out in space. But again, I'm going to need that point, right? So that's why I made that line on top of it, because I'm going to need this point at the intersection. And then I'm going to rotate it one more time. And so there's 1, 2, 3, 4, 5, 6. So there's 6. And by the end, I want it to be at 0 degrees. So I'm going to rotate it 5 minus 1/6. And it's going to be a little bit less rotated than the one before it. So you'd basically go down and do that. So use the same airfoil down the line. And I'm just going to pop, I don't want to take our time to do that. We have 8 minutes left. So I'm just going to pop over to this one that I made earlier, right? So same thing. And then what you do is you create a loft. So let's go in. So this is a solid loft, but you could also do a surface loft. So loft, and then I'm going to click all of those profiles. So 1, 2, 3, 4. It's giving me a hard time, so I'm going to hide the canvas for a second. There we go. Oh, wrong profile at the end. Oh no, that's right. Okay. So I hit OK. And now I have this, I'm going to hide the sketch now. So now I have this pretty nice airfoil here, this wing, right? You can see how it curves slightly, right? So if we do a inspect section analysis here, and we drag this through, you'll see how it kind of curves up. Or if maybe that's better to see over here, right? So this is the edge. It kind of curves up because we had it rotate less as we went down the line. And then what you can do from there, so I'm going to delete that just because I already made one. What you can do from there is you can mirror it. So now you have 2. And then what I did, which I will show you how to do, is let me hide all this stuff, is I actually wanted to do a loft of the body. So I made a really quick sketch that was just circles. And this one I did with just one plane because I didn't need it to be as parametric. So I just made a circle, dragged it forward, then copied and dragged it back, and each time reducing the diameter a little bit. And then I was able to do a loft between them. So I think that maybe we'll stop there. We have another workshop. So maybe I'll pick up here next time and I'll talk about doing this next loft. Because we have one more next week. So I think that would be a good topic to finish out. But we have 5 minutes left, so maybe let's just do some questions for the last 5 minutes. Yeah, I think that's what we're gonna do. Yeah, so any questions or anything about it that I did that was confusing or why I did it?
I just have a quick question with regards to the simulations. So I know you mentioned some programs that we might be able to use. Would you be able to just elaborate a little bit more on some like Autodesk programs we might be able to use for simulations and such?
Yeah, so you're talking about for generating the airfoil profile or for doing simulations on its aerodynamic qualities?
Yeah, for doing simulations on its
Sure.
qualities and how it performs.
Sure. So our product is Autodesk CFD. It's available for download on the education website, the same place you downloaded Fusion. So autodesk.com/education. The product is Autodesk CFD. Basically, you import a solid body, or actually, you probably could import a surface body as well. You import a body into CFD, and then you put in boundary conditions. And then you can simulate basically coefficient of drag, coefficient of lift, and analyze your foil in a bunch of different ways. I'm
Got
not
it.
a CFD expert. I've used it twice. So that's not something I can really do a workshop on, but there's a lot of YouTube videos and a lot of like online content about how to do that.
Thank you.
Yeah, but that's yeah, that's definitely the on the computation side, like the way to go.
Sounds good.
Yep, good question. Other questions? Do folks think that they're going to use these modeling techniques to create their airfoils, or is this not the way that they were thinking they were going to do it? Curious.
Yeah, personally, I was thinking a lot about how I would create such things on like Fusion 360, but I wasn't aware of the features you mentioned today, like the loft and the spline. That makes it way easier. So if I
Okay,
was doing
good.
something like that, I would definitely be using it.
Yeah, this is the lofting technique is what kind of came up when I was first thinking about creating the airfoils. So it's neat to actually see the process and doing it the way you did. Really good. Really
Okay, great. Good. Well, I hope, yeah. So this one I use because I was using the airfoil profile from the website. That's why I kind of made all the planes and I had to import it every time. If I just wanted to do a spline that I drew myself by hand, that would be much easier to do because I wouldn't have to import it every time. So I would just make a bunch of planes and then copy and paste and drag each one to those planes. So I can show you quickly how to do that. So like here's an example. Um, so like, let's say this was just something I drew and I didn't need it to be precise. This is actually another airfoil, but like, for example, I can just I'm in a sketch right now. So I would just, once you're in a sketch, you do Control C and then Control V, and then I'm going to pull the copy out, and then I'm going to do a point to point move. So I'm going to click the best point, and then I'm going to click the, where is it? The middle, I want this middle of this. Sorry, 1 second. Just did this. Oh, I see. Okay, that's why it's not working. I'm gonna move this down just slightly. Okay, now I'm gonna do a point to point move between this point and the center. So the reason this wasn't showing up is because it was already like on it basically. And so what that's gonna do is snap it to the middle. And then from there, I can scale it. So maybe I want to scale it by this top point. I'm going to scale it to 0.7. And then maybe I want to move it again and I just want to rotate it about this y-axis by, 2 degree or 2 degrees or something. And now I have that. So you can also do it by copying and moving it to the place you want it to be and not importing every time. But the nice thing about importing is that you get to set the chord length. So the chord length is the distance from here to here. And when you set the chord length, the only way to set the chord length is by importing it every time using that add-in. But if I don't care about the chord length or I don't need it to be precise, I can just copy and then paste it and then move it to a different plane, and then I can scale it. And scaling it is like a percentage of the size, so it's not going to get me to an exact length unless I calculate it. But this is a quicker way. And the way I did this, you can see it's only 4 moves, right? So in this one, what I did was I have to get out of the sketch, sorry. What I did was I made a sketch here, then I did a patch. So this is the patch command. I just made a surface, and then I rectangular patterned that surface. And then I brought in an airfoil, copied it, moved it, anchored it to one of the patch profile or to one of the patch planes. And then I just kept copying and pasting, anchoring it to different profiles. So this is all one sketch, just anchored to different profiles. And then when I'm done with that, I can just do a loft. So I can either do a surface loft or a solid loft, but here I'm just going to do a surface loft. Oops. So I'm going to hide those patch things that I rectangular patterned, and there's my wing. So there's lots and lots of options for how to do this. These are just a couple of them. All right, sweet. Well, I think we're going to end there. But we have another one on the 24th. So I'm going to finish that plane example that I did on the 24th. Yeah. Thanks, everyone.
Thank you very much, Gabby. And thank you very much for coming.